I'm Nathan Brandt with Cole Ironworks. Today we're going to do a tour of Cole Ironworks where we build hydraulic forging presses, power hammers, air hammers. We do dies, all kinds of stuff right here in Anderson, Indiana. So come on inside. So you'll see our C. So we have a line of induction forges and chillers. We build a complete unit, and we sell that into blacksmiths, ornamental metal shops all over the world actually. And so we just got our shipment in of those. We get about 2 shipments a year, and then those get stocked up. But this end of the shop is our raw material. So this is going to be 954 aluminum bronze, H13, 4140, 1018 cold rolled, all that stuff. We bring in small quantities. On that back shelf, we hold just a little bit of excess stuff for making jigs and fixtures and stuff we need around the shop. But we keep a relatively lean raw material inventory, but everything comes in and gets processed through here. So this is the newest machine in the shop. We bought this brand new. We didn't buy anything else brand new. And this is our big hide mech. I think it's a 32A, if I remember right. It's been a minute. But all of our material gets processed through this. We were previously using 2 auto feed Cosin saws from the 70s. And I was going through about a blade per day. And Nigel runs this now for us. And I can get 9 weeks, I think is the most, maybe 10 weeks. He'll holler at me if I'm wrong, on a blade, which is great, but we're getting way better precision. But we'll keep a very, very small inventory of high movers. So just stuff that we make a lot of. We'll go ahead and keep that bar processed and out of the shelves so it's ready to go, because we turn that inventory over a lot. And then you can come in here. So this is the CNC department. There's Nigel. And in here we've got a ProtoTrack Bridgeport for one-off stuff. Use that very rarely. Almost everything in here came out of local closing down industrial shops. Everything's from the 90s. I think this might be our oldest mill, but it's got a next-gen controller on it. And most of our parts are very, very simple. We don't do a lot of complicated machining. So, we just need tight tolerance on hole placement and simple parts. So we've got some small Fadals that we run. This is our biggest one. This is a 5020, the beast. And everything's CAD and cammed in Fusion, and then just drip fed into the units through USB. And get some fun stuff in there. When we got this one, the coolant was still in it, and it had been, I think it was oil, and I found a bird in it. It had sat, turned into sludge, so we've had to flush this one a few times. This is a relatively new machine. So this is a ST25 out of another local shop that was closing down. So the upside of all this industrial closure is that we can find screaming deals on really good quality equipment. So this has been kind of a learning process. Nobody here has ever run a CNC lathe before. Comes with a bar feeder. We haven't used the bar feeder. Almost all of our parts are super simple, just like this. So this will be a blank. This is H13. We turn this shaft down to exactly 1 inch, and then it goes into a mill and gets a divot machined into it. That becomes the work holding. Then we can 3D mill our punch shapes out of this. So these create, and I'll show you in the shipping department, but these create specific size and shaped holes in a hammer head, right? So we need to make a hammer handle shaped eye in that. So we have a tapered progression to stretch the material out, and then a finished size that matches the handles that we sell also. So when we're doing product development, we're thinking about full system for the customer. I want to sell a machine that can punch a hole that fits the handle that we also sell. So we size all the products, and so that they all work together for that. We have, most of our products are an assemblage of purchased components. So they'll be from all over the world. We primarily try to go after US, but a substantial amount of the parts are US steel, US bronze, stuff like that, that we'll do all the machining on. We now have two products. One is our KA75. That machine is 100% made in the US, and 98% of the products we make right here to assemble the entire machine out of. So super, super proud of that. And then the power hammer, 100% US. The only thing is the motors that we have to buy for those. Everything else is 100% made in the shop. And so we'll see some examples of those around. But this gives us, these 4 machine mills and 1 lathe give us the bulk of our machined parts. And so we'll walk over here and talk about how we do things. You'll see stuff in bins. So right here, between these 3 pallet racks is our supermarket. And so everything that we utilize for fabrication and assembly is kept in a Kanban system. So every part, there's always going to be 2 bins for. Now in this case, the parts are large. We use the forklift to move them around. So we have pallets. And you'll see on here, we use one of those fancy printers to put it on. And we tape on a Kanban card. Super, super simple. It just gives the part number and the supplier. These are totally kept in an online database so that we can track quantities and place orders, but we always use a manual method to reinforce that information. The inventory system gets off sometimes. Kanban systems never lie. So these are all of our fabrication components, and we can go over here into our little fabrication work cell. So he's pulling parts off the rack to fabricate. We use a rotator, and for the bigger parts, for the smaller parts, he's got these little jigs and fixtures. Josh, say hello to the camera. And so he's making one of our 12 tons right now. So in-house, we design and build the fabrication method and any jigs and fixtures right here. And then back here, we've got different carts for different product families. And then he's able to go through and assemble. And most of the assembling is to order. The 12 ton is the only one that we'll make some extras just because we have such an inventory turn on those. Back in that department is all the stuff that's not used in production that we just like to play with. So right here is a really important part of the system. So Kanban means signal. This is our signal board. So as Greg, our assembler, or Josh, our fabricator, is pulling parts out of the supermarket, when he gets that empty bin, he's going to pull that bin and set it here. And that tells our guys, whether it's our CNC department, but specifically our inventory manager, what needs ordered. And then he'll give a manufacturing order if we make it, or he'll send out a PO to our vendors to supply it. So this is a queue of things on order right now. And you'll see the different bin sizes. These beautiful, very, very, very expensive Worth bins are super fancy. Pick those up at a local plant closure. They weren't lean enough, I guess. So in here is our supermarket, and we've got some stuff in process, so it's a mess right this second, but the basic process is really, really simple. Every part in the supermarket gets 2 bins. Every bin has a label, and where it goes on the rack has a label. Nothing doesn't have a label. These are just pieces of paper. We laminate them so they never move. Some of our bigger products, which we make it here in-house, especially ones that sit for a while, we won't use a bin for because it's not feasible. But relatively everything, any small parts, bolts, nuts, fittings, accessories, everything gets Kanban so that it never gets missed. So like I was saying, when Greg uses the last quarter 20 by 1.5 bolt, he pulls this out. He pulls the next one down. And then you open that up and you've got your next quantity for utilization. These bins are fancy, and I bet they were really expensive. But it doesn't matter if it's those bins or it's just these. It's going to be the same system. So when I pull out this front bin, there's another bin full behind. So my producers are never in a position that they have to stop producing. That was something that we learned in the very beginning. We tried to put multiple products in a single bin because we were cheap. And then half the bin would be out and the other part, it's 2 bins per part. Everything has a label. And I tell my guys all the time, if they see a label on the floor, immediately take it to the production guy. He knows where it goes. If one gets damaged, replace it. They're cheap. They're borderline free. We just store all of these little card pictures on Google Drive. So if anybody needs access to it, they have access to it. And it's super easy to maintain. It's not super clean just because we're busy, but you know, everything has a bin. Everything is where it needs to be. Any parts that aren't in a bin, something like this, that means that we're phasing them out. We're not going to be utilizing them. We might use them once every 6 months. So we just leave them there because the guy that is going to need them has access to them. But once they're gone, we will not be placing a reorder. That's why they don't have a bin. So you'll see a mixture of parts that we buy, like these, over to parts that we make, little bushings. Again, these are a part that are being phased out. So part of why this is so messy is we just brought on this product and we're learning how to build it right now. And so we're getting real-time feedback as we're building them about what parts need adjusted, what parts don't work anymore. It doesn't cost us any money to pull a little cart off the bin and take the bin away. It allows us the flexibility. The guy that's assembling is the same guy that's giving real-time feedback about what's working and what's not. And we just wrote that right in. So we're establishing this system right now for the KAs. We've got our basic tools organized and per drawer. It's still messy. We're figuring out which tools we're not going to need. We thought we needed and we put them in the drawers. We'll have stuff in here, you know, that it's all stuff we made, or in this case, the shop that was making these before us gave us. But everything's relatively organized and we know where things need to be. These are some more examples of the parts. These are all made in-house. It's just cut to length. It's got a cross drill. These are the parts. These are bread and butter for our machines. And you know, the saw cuts accurate, and those can do that one hole. These are lathe parts, so these are a little bit more in depth for us. And like I said, we don't have a background in lathe work, so these have been interesting. Up to big parts like this. This is for a retrofit for a K75, and so we're actually going to be modifying this one. But these are about as big of a part as we get. Those 75 pounds, and once they're assembled, then they are 100 pound. But we do all that in-house, and these have a really cool mechanism. So we make these, and you'll notice there's a taper on the inside of this, and then it's just saw cut, and we throw an O-ring on it, not because it's not a gland, it doesn't seal, but what it does, let me see where my taper pins are. There's a tapering pin. In one of these. Taper pin, look at that. So this is some all thread that we cut to length. It's got a taper that matches the taper in here. And what happens is on the finished unit, beautiful, thank you. So you'll see these O-rings again aren't for sealing, they're literally just for placement. But as you tighten this taper pin, that outer collar expands. And so this is what actually attaches the ram to the cylinder. So as it gets tighter over time, and as it's impacted, it actually gets tighter and tighter and tighter. So this will never separate, but I don't have to weld it. That allows me to keep a nice clean bore and have a replaceable component that I don't have to cut apart. So that was really smart. So over here is our assembly cell. We're doing some repair work for an industrial customer right now, but everything's clean, well lit, all the parts needed are available. We have our tool board on the side, but these are really cool. So these are an example of simple but effective everything that we make in the shop has a poka-yoke board. Here's a good one. So we call these poka-yoke boards. So everything is cut into the Kaizen foam. So when Greg's going to go and pull the parts out of the supermarket, he has to fill for that product, fills this board. When it's empty, his project is done. He's not grabbing 50 bolts and then losing a few. No, he's grabbing the exact number of fasteners, the exact sizes. If he got the wrong fastener, it doesn't fit into the cutout, which helps him make sure that he's never using anything he doesn't need and keeps everything really neat and tidy. These have been super effective. Now, you know, as Greg gets more proficient, he's been here a while, he's just a very good operator in everything that he does. He can rely on these less and less, but especially when you're training somebody in a process that's never done it before, these are a godsend because they give you immediate feedback if you're grabbing the right part. And it's important to have that clean cut and not just a bin or something like that. It needs to show if the part's correct when it goes into the board. And that's why it's a poka-yoke board and not a pretty good board. So you'll see a freshly painted press right there. That's our 25-ton H-frame. So these are, we fabricate the tanks, the electrical system, full assembly on the power unit. This is 100% except for the cylinder, manufactured in-house. So we've got these adjustable Gibbs systems. We do the bronze, they're 954 aluminum bronze. We machine the T-slot platens. All that's manufactured here. It gets machined, fabricated, assembled right into the paint booth, comes out of the paint booth and sits here as it dries, and then that order is packed and shipped. So we are making to order in almost every product family. Like I said, the 12-ton will carry a little bit of inventory on the frames just because we turn them over so quickly, and that gets them out of the shop faster. But everything gets painted and then pulled over once it's dry. Actually, I'll show you a couple things on here that's fun. So one of the things that we struggled with in the beginning was we wanted to assemble these and not need to disassemble them for paint. And so what we found is we just use this little plastic stuff. You can slip that all over the cords and keep the cords from getting painted during paint, and we'll throw the mag starter and stuff in these big plastic bags so they don't get painted. But then you can just fly through and paint the finished assembly and everything's done, and you're not disassembling and reassembling or anything like that, which can bring mistakes to the forefront. So over here is shipping. So shipping's got their own Kanban system that they're operating out of. These parts aren't used anywhere else in the shop, or they would be on the bigger supermarket. But it goes from paint to packaging, and it goes out the door. And we have the capacity for the lead time to be less than 1 week from order placed to a delivered product, including freight time. But we try to manage about a 2-week lead time to the customer, because we found when we got it down to less than a day, people weren't ready for the product to show up. You know, these are big machines. People are building shops and getting excited, and so it was too fast. So we backed off a little bit to give the customer time to prepare, make sure shipping's in order and all that. But we ship all over the world. We have shipped overseas. You know, I've got these in Rome, France, Greece, Scotland, UK. We were recently featured on We Are Makers podcast, and they were just in France, and one of our presses had gotten tooled up and was making the timber framing tools that the carpenters were using when they were rebuilding the Notre Dame Cathedral, which is super, super cool. So this is super messy, but it's very effective. We collect all of our incoming shipping boxes, we grind them up to infill. One thing that people will not tell you is how expensive packaging materials are. And so we're able to turn a waste product, instead of paying to have it taken away, it all gets ground up into this corrugated, and then we pack our boxes and our small parcels and all that with those. And you can see we've designed our shipping system ourselves. We have these pallets made just up the street at a local pallet manufacturer, and they are sized to our product based on experience. We used to make our own pallets from scratch, but we have them make them for us now. They're pre-drilled. The presses have tapped bolts in the bottom plate, so we just bolt them through this 3/4 inch plywood to the pallet, so even if it tips over, it doesn't fall off. And then I have no straps, nothing's gonna hurt the paint. And we put this on here twofold. It protects it from moisture and rain, but it also ensures if this is torn apart, you know that the press has been damaged, and that protects the customer in the event of an issue during transit. So over here is our shipping department. So we've got some computers, some fancy people. There's Francis, our GM. Hayden is running shipping for us. He's in training right now. All of our stickers are Kanban. In here, we hold a small quantity of everything in shipping, and the shipping Kanban system is a little simpler. Stuff that doesn't move very quickly will have a single bin because it has to be assembled. So when that bin is empty, Hayden will just go over, build these little kits, replenish, and put back on the shelf. This isn't as time sensitive. You just fit these in where it needs to be. But we sell a lot of materials. So like if somebody wanted to buy 3-inch H13, they'd have to buy a bar, and a bar might be $5,000. And so what we do is we cut it up into small usable chunks. That specifically we cut in half so that customers can make their own rounding dies really efficiently and economically. We stock, so like I was talking about the hammers earlier, if you want to make a 3-pound hammer, here's your starting stock. We've already got it cut to size. It's 1045. You're not buying any more than you actually need. We've got some exotic materials. This is some of that 954 aluminum bronze, which actually forges beautiful. So we've got it cut into little pre-sized blocks. That'll give you like a 6-pound soft blow hammer if you want to forge out of that. And different options there. This is a fun material. This is called Flutagon, and it's called that because they use some kind of vacuum process in the making of the steel, which results in this shape. And this is specifically made for blacksmiths. So you can roughly heat treat this. Doesn't need any temper, don't need a kiln. You take it out of the forge and you quench it in water, and it's hard. And I mean, it's very hard, very tough stuff. We've got that in a bunch of different sizes. We have to buy a truckload of that at a time. You cannot just buy it from the manufacturer, because when you order it, they make it. And then they load the truck, it comes here, and we break it up into these little segments. So again, you don't need to buy a full bar. You can buy just the stock that you need. Same thing with this. This is a punching lubricant. You have to buy this by the semi-load. We were able to talk them down to a 55-gallon drum, so about a 500-pound drum. And then we size it into a little usable for hobbyists, blacksmiths, people that aren't doing huge quantity. If somebody needs a large quantity, we can still provide it because we have that relationship with the manufacturer. But we sell a couple different versions of those. You know, we bottle these ship with every press. You want to make sure your press is lubricated. Moving over here, I was talking about punches earlier. So here's an example of one of those punches. So they lathe this down, it goes into the mill, it gets a 90-degree in-mill spot. That's going to locate that in the collet system that we design and make here too. And then they set that up, and they're able to use a very fancy shell mill and just 3D contour. And when we learned to do that, we went from about a 3-hour-long machining process down to about 20 minutes. And so that allows us to sell these a lot more efficiently or economically, which means more people can get very, very helpful tools in their shop. And we have different sizes. So this is a hammer eye punch. You'll punch the hole in that billet, and then you'll size it. So each one of these is designated to a numerical valuation that corresponds to the hammer handle that we have. Make sure I put those back in the right spot. And so you can buy you know, a number 5, and then on the website it says number 5, and there's a little tag on here that tells you what size it is. But that then corresponds to the eye on the hammer handle. Hopefully don't get those too dirty. And that's same for axes, hatchets, different stuff. So we hold some specialty dies. These are for knife makers that are doing Damascus and want to control the pattern. It's called raindrop. We hold a little bit, but you'll notice some of these aren't on die plates. And what that allows us to do is I only have to hold a few blank die plates at a time, and then I can make 5, 6, 7 different die options. So I'm holding it at the point of versatility. And so I can make butcher dies, I can make flat dies, I can make drawing dies, I can make rounding dies, yada, yada, yada. So I just bolt them on. So we use little countersunk bolts that go in and thread up into the bottom. These are made out of H13. We have a local shop in Muncie that does all our heat treating for us. H&H Heat Treat, and that's Brandon. He's my best friend. And so, you know, a lot of these parts are really simple, but like this is a solid block of 4140. We go in and make all of these machining. It's op. We use this as our mounting op. So this is a great option for fixturing. We can fixture a bunch of these on a plate, which again helps the efficiency during machining time, cuts that cost down, and also helps with capacity because, you know, I can have 2 guys running 5 or 6 machines, no problem. So yeah, a lot of different options. These are one thing that we do buy, we hold a lot of, just because it's a lot cheaper to pay for an entire plate to get cut. If they only put 1 plate on the Plaz, then I get all of these parts, and these are, you know, these aren't going to change. These are based on some of the dimensions of our dies that are fixed that we won't be changing. So this is an example of a punch set. So this goes into the press. It has that same conical tip point. This little die tenon slides in, and there's a conical tip set screw that comes in and engages that. And we set it up so that this is 5 to 10 thou below, or I'm sorry, above center line. So when this comes in and engages, it's actually pulling the die down into the die holder. And that helps with repeatability and holding power. So these dies aren't going to move, even though something that a lot of other press manufacturers will just, they don't have a tenon. They just have a plate with little holders and they slide in. And so when I'm punching and I'm stripping that hot steel off the punch, there's a tremendous amount of up force and it can just bend those holders, and now you've got a real problem. So this not only locates to the exact position on the press every time, but then you have a ton of clamping force. And so these punches fit into our collet system. So this is just a simple DOM, same thread size. Those go in and it's the same engagement. So this is being pulled into the hole by the tapered set screw. So we tried a bunch of different stuff. We used, before the conical tip, we used a mobile, I can't remember the name, what's it? Swivel tip set screw that would slide, and instead of using that conical depression, it was an angled flat. And so you still got some hold down, but there was no repeatability. And that gave you better adjustment, but you couldn't set it and forget it and have it be the same every time. So that's a huge improvement for our dies that was just iterating over the last 10 years of different methodologies. We've kind of expanded now into some more complicated die sets that are specialty. So this is an example of one where there are little T-nuts on the bottom that allow you to adjust placement, and you can have multiple dies on one die set. So if you're forging a hammer, that allows you to have a bolster to punch your drift through and then forge out on the fullers. And we just hold small quantities, and when the order is placed, they put the pieces in the box and ship them out. So that's pretty much our shipping department. And you'll notice Greg, everybody kind of does everything. We're a small shop, we only have a few guys, and everybody helps one another and works together. Ultimately, our whole goal here is that the customer gets the best product possible, and we work as efficiently as possible to keep our overhead low, which is why we don't hold a lot of inventory and we don't have a lot of staff. So we can come back here now. So this is our only air-conditioned and temperature-controlled workspace. And Ryan works in here and he builds our DPCs, so our digital press controllers. And you can see everything is SOP'd, labeled, Kanban'd. All the Kanban and all of the inventory is managed in this one space, so it's not spread out over the whole shop. So he's got replenishment behind you, Kanbans in situ, checklists for each. So we designed this from the ground up. We build them 100% right here. And then we designed our own software that he's got the computer to upload the software at the end of the assembly cell. There is a build sheet that everything is color coded and followed and checked as he's doing it, because there's a lot of small connections that need to be monitored. Then everything is serialized, put together in this box, and once it goes through assembly, gets its software installed, then it gets a final label that serializes it, so we can track back through which customer has which controller. And you know, anything that comes with technology, we need to be able to go back and see where we were, see if there's any adjustment in what peripherals or what kind of control systems or whatever. We also make these in-house. These are super cool. So the joysticks to control the press, we use an off-the-shelf joystick, but we 3D print a box, and we use a little mag switch that sits into the 3D printed. The covers used to be 3D printed, but over time they can wear out from this back and forth movement. So we're now using anodized aluminum plate. We just laser this out. We have a laser in the back, I'll show you. And then you're able to move this anywhere around the press and click it on, and you've got a mobile control system, which is super helpful for our presses, because we used to only have at most a control cable to a foot lever that manually actuated. This gives you full control of the machine anywhere around the unit, including if you're standing way far back and need to control the bar while you're forging, you can. So super, super proud of all this, and that we're doing it right here. You can see our fancy little tool board there. This was kind of the implementation of the Kanban system and some of the SOP systems that we've now developed for the other side of the shop. And you'll see here, these are specialty controllers. So these use a separated screen. See if I can turn this over without making a mess. Separated screen that goes on the front of the press, and then the press controller goes on the back side. Those have the control panel built right onto the front of the press. Here's one from a customer that had a shop fire that we've gone through, refurbished, function checked, passed, made sure everything was good. So we'll save this for a special project. Everything works, but it's a little smoky. So you've got some prepped boxes ready to go into assembly. And over here, we've got our peripherals staged. As he's got time, we just have him make a few extras to make sure they're ready to go. And he's got to go through and check the encoders and check functionality, make sure that it's got the correct connector on it. Before we get to the actual production stage. Now in here where these two gentlemen are working, this is our R&D lab. This is Logan, our lead engineer, and Charlie, our engineer in training. Charlie is a world-class knife maker that runs our school, which we'll go look at next. But he's helping get, these are the power hammers that I was telling you about, where we've made every single component on these nearly, excluding of course the motors. So our motor division will be next. So we've got a bunch of fun tools in here. You know, toolboxes full of fasteners, end mills, taps, dies. We've got a old Victor lathe, a really beautiful Bridgeport with all the fixins, and then we R&D parts and processes out of our Haas. So this is a very old VF0, and it's got the Pearson pallet, of course, and a very, very fancy orange double vise. But this allows us to test parts and processes in the development stage, check cam, make sure we like what we're seeing, we've got the proper tools, we can hand it off then. This mill, I'll give you a little secret. So I was at a closing auction for a factory where we bought the lathe, and I was looking at the mills, and they had a bunch of really nice mills, all Haas, much newer mills. But this was the only mill that I was able to walk up to the control panel, power the machine on, and jog the axis. And that told me base level functionality is here. I paid $1,400 for this mill. I drove down, they loaded it on my truck for me. We brought it back and had Haas come out and just fine tune a couple things. This back way cover was gone, so forth and so on. So it's you know, all of the mills that we run are very old. They're quirky. You do have to work with them. They are maintenance hogs on occasion, but for, let's say, $2,000, I've got a machine that can do anything I need it to. We're doing a lot of steel, a lot of tool steel. I don't need super high feeds and all that. I just need to be able to make the contours and the shapes that would be very complicated to do on a manual mill. Manual mills are still used in our production, or not in our production, but in our development absolutely all the time, as we're figuring out what we're doing and when and all that kind of stuff. So got a top secret project right there that nobody can know about. And then, so other than that, that's our shop tour as a whole. This is our production shop. We'll move to the back. This is our school where we do forging training and development. And this is the part that Charlie's responsible for. So if it's messy, it's his fault.
I've been on vacation.
So the whole building here is 43,000 square feet. It's roughly an acre under roof. Before this, it was a Budweiser plant. Right before we got it, it was a casket manufacturer. They had some of the largest CNC routers I've ever seen in my life, 50 horsepower spindles, just monster machines. So this is our school, Cole School of Iron. This is where we host classes. Every last Saturday of the month, we have a free IBA meeting, Indiana Blacksmith Association. So people come from all over the state and they just get to do stuff, right? So, you know, we've got some of the biggest anvils you'll ever see. This is a forged 716 pound, I believe German anvil. If I'm wrong, the internet will tell me. So that was forged, usually out of a bunch of different pieces. They forge weld the different pieces together and then weld on a cap of tool steel. That's the biggest anvil for sure that we have. This is a really cute Soho pattern. So we've got really cool tools. Here's one of our KA75s like I was telling you about. So those glands are here. Those hold the cylinders in. And then one cylinder lifts and one cylinder pulls down with force. So you've got a 100-pound ram that's being pulled down under whatever PSI of pressure you're feeding into it, usually around 100 to 120. Greg recently took his personal one at home up to 160 and it ran super great until he blew the seals out of it. So maybe not that high. So you can see our press controllers. The gray ones are older. We've moved now. We have these enclosures. We used to buy the enclosures and use a skill saw and cut the holes out. Hole saw for these, and then the square ones we had to, you know, go in there manually, cut the thing out of the front. We now have them made, and what's cool is they can go ahead and powder coat them this textured black, which is super nice because you don't see all the oil and fingerprints and grease and stuff, so it stays looking fancy. And these allow you to control parameters on the machine. We use a rotary encoder that monitors position of the slide at all times, gives that feedback to here, so you can see where you're at. And when you're walking around your shop and you're not sure if this is 2.5 or 2 1/4, you set it in there and you close it, and it's the most expensive set of calipers I've ever seen, at least the largest. So you see we've got our C-frames. This is a 25. This is a 16 plus. That means it's a 16-ton press. The plus designates it's got the larger power pack, so it's a much faster machine. This is our new H-frames that we've been doing for the last, year and a half, not super long. You're able to adjust the gibs. It's got a lot more rigidity than a C-frame does. This is our early power hammer, which is currently in pieces because something broke and they were fixing it. And yeah, so we host classes. One of my little side adventures as a business owner was to buy up a bunch of ex-industrial machines. So these 4-post 120-ton presses I bought from a stamping operation, I think out of Pennsylvania, and they had 7 of them, I think. And so we brought them in and built we machined the T-slots, installed those. This is 8-inch solid steel that's been just rough cut out. And then there's big bronze bushings in there, and then you can see
that whole thing is the cylinder.
That is the cylinder. This is the rod. This is a 9-inch rod on a 10-inch cylinder. And then we build these big power packs. That's our 10 horsepower power pack. This is a 60-ton H-frame. You can see it's bottom acting just because if you flip it over, it gets super tall. And we machine all the components for that. The only thing we buy are the cylinders and the bolts. And right behind you here is one of our induction forges. I'll see if it's hooked up. So, make sure it's got water in it. I think so. A really easy way to check is to open that. But have you ever seen one of these?
I have.
So for your viewers that haven't, so what this allows you to do is heat your steel up in a very controlled manner. It's mad at me. I let the water get too low. Very controlled manner, and only forge what you need at a time. So for these, we make these little skull keychains in our class, and that allows you to bring someone in off the street, and you can see this is a good example of manual machining here. This was a custom die that we made to make little skull pendants. This fits into one of our 12 tons, and then you put the little piece in, you squish it, you do all the work. So this is heat treated, the rest of it's just mild. But we can make this in an hour because we've got the manual machines. We don't need a CAM program. We just need to make some chips. So that lets you set all those parameters up, do them quickly, come up with new ideas, experiment. The school as a whole is an experiment. We host classes. We also do what's called a minis, and you can come and schedule a 30-minute or a 1-hour class with us. You can make a pan. You can see our pan die in here. This is kind of fun too. So this is just a plasma cut plate, and then we machined the rim, and then up here we just had the cutout and we machined it, and then that allows you to stamp your pan blanks. And so you can come, and in 1 hour we'll make a carbon steel skillet together and send you home with a really beautiful heritage kind of tool. You can see a finished one here. Got the riveted copper.
Yeah,
Come on.
Copper rivets.
Come on. We're going to forge these out. We have another little die that lets you forge that little thingy there. And so, yeah, this is just an effort basically to make more blacksmiths, expose as many people as possible to blacksmithing as an accessible option as a hobby, but also like there are industrial utilizations. I'm currently personally working on contract forgings for companies all over the United States. And I'm a small, low overhead shop, so I'm able to be really effective at doing small batch work. When they're just getting started, they're testing a market, I can make a small batch for them, and it might be more expensive per piece, but my setup costs are almost nothing because I've got the capacity and capability here to manufacture my own dies and tooling. And so we're experimenting with that right now as a kind of a viability check on cottage industry, small manufacturing on the forging side, with some limited machining and things like that. So that's it. That's our whole shop as of today. I will take you over here real quick. I do have one more thing I just remembered. So this is our red tag room. So machines that are pulled out of production get stored here for a while, and then we've got our surface grinder and mills that supply capacity over to the school for one-off operations and simple little doodads. You can see that's a belt attachment that Charlie built. It's kind of fun. So it's locked so you can do a belt change, and then really easy to change different grits and things like that. So this is super cool. So we have a pair of lasers here, and one thing that, see how hot this is. I'm not going to touch that. One thing that we do in-house is I can take a CAD model or just a PNG image and convert it into light burn, and then I will use the 60-watt laser to engrave that surface down so I have a one-to-one reproduction of that image. So this is for Best Made company that I'm doing axes for, and we're going to be releasing a smaller axe, so we needed a smaller thingy there. That's another axe for another company that I'm forging, and this gives us like a superpower as far as engraving, because our mills are old. They have 7,500 RPM spindles. They're not going to be engraving anything. This lets you get all these tiny, tiny little wire details, no problem. I engrave them out of H13 and then go over to one of those induction forges and heat this part to a glowing yellow, which is what you want for H13. Now I've got a hardened tool steel stamp, and you know, this is a cutoff of a bar. This is scrap. So we can kind of continue to bolster our capabilities with some really simple tools. And then we take on some local job shop work where we'll be doing engraving with the lasers on some local aluminum component boxes and things like that. So it's just kind of always repping on and iterating on how can I serve the local market, maintain production, utilize a little bit more capacity, leverage what we're learning on a consistent basis, and just continue to iterate and grow and try new things. And this is fun too. This is number 3 and number 1. So this is the first. The third forging press we built, and you can see it's leaking. And we used to buy I-beam from the scrapyard, and then we had a local shop that would plasma cut some parts for us. We would drill all the holes on the little Craftsman drill press back there, and then it got welded with a MIG welder. First a stick welder, then a MIG welder, and then now we're using the big boy spray transfer welders. I learned a lot about weldment design because of these. We used to have, in the very, very beginning, these would crack from that force application, and so I started over welding them, but then I realized we could move to the plate, transfer the load without any welding, etc., etc., etc. So, but some really fun firsts there for the company. This guy was over I think in Columbus, Ohio, Adlai. He runs a school over there for blacksmithing, and we reached out and said, hey, we want this back and we'll give you a new press. He was like, yeah, that's fine. So, but a nice little taste of history. Well, so we share this space with another manufacturer that does high-end dog food. And so they utilize this space. They've got a cool room back there, another 7,000 square foot shop. So they use this, and then we use the docks this morning. We help each other out as we need to. But I don't need the space yet, and happy to share it with another local manufacturer while we iterate on what we've already got. And we've got room for expansion over time, which is incredibly important and very rare. Usually room for expansion means I've got room to build more building. In our case, we just have to move over. So yeah, that's pretty much it. That is our production processes for Cole Ironworks. Again, we build hydraulic forging presses, power hammers, single blow hammers. We do dies, tooling, custom solutions on that side, and induction forges, all kinds of exciting stuff, and a lot of new stuff on the way too. So.